Okay, geometry, into what we're calling part B of section 3.8. So in 3.8a, we talked all about how to find the slope of a line, and now we're getting into the first of really two, kind of three, forms of linear equations we're going to deal with. So in this section, we're just talking about slope-intercept form, which again is hopefully something you guys remember at least a little bit of from last year in Algebra 1. So slope-intercept form is the most common, the most well-known, really the most useful of the three forms of linear equations we're going to learn about, and it looks like this right here, guys. Y is equal to mx plus b. So that's the formula for slope-intercept form, but a formula is no good to us unless we know what all of those variables stand for. So within this formula, y equals mx plus b, m is equal to, hopefully you've guessed it, just like we talked about in 3.8a, m is the variable that we use to represent the slope of our line. B then is something that we didn't talk about in 3.8a, but again, hopefully you recognize. B is called the y-intercept of your line. And then those are two things that most people can usually remember, but people sometimes get tripped up on what the x and the y represent here. And really what they stand for right here, guys, is any point that's located on the line in question. Okay, any point on the line in question can be substituted in with its x coordinate here and its y coordinate right here. And when you plug all of those values in for one particular line, where m is your slope, b is your y-intercept, and the x and the y represent the coordinates of any point on the line, you should always end up with a true equation, something like 5 equals 5. That should happen no matter what point you choose. If you ever end up with a false equation, like 5 is equal to 6, no it's not, that would mean that you messed something up somewhere along the way, and we would want to go back and fix that. So let's see slope-intercept form in action, guys. The first thing we're going to do is give you three problems here where you've been given a graph and you're asked to come up with the equation of that line in SIF is the abbreviation we'll use a lot for slope-intercept form. Now, I really want you guys, and I don't know if you did this last year or not, to pay attention to the words in the name of this form. It is called slope-intercept form because you need two key pieces of information in order to get it. You need to know the slope of your line, and you need to know the y-intercept of that line. And those are two key pieces of info we ought to be able to get just by looking at the graph. What we're going to have to do first, everybody, is figure out the slope of this line. And to do that, let's remember what we learned in 3.8a. Rise over run is the way we figure out slope. So you'll notice on these problems, I gave you two particular points. I'm going to say that this one is point A, located at 0, 1, and then point B is going to be located right here at 6, 5. Now, what we could do, everybody, is use the formula for slope that we talked about in 3.8a with these 2 points right here to come up with the slope. But since we've been given the graph, it's probably easier to remember that slope is the concept of rise over run. And with a graph, we might be able just to count our way from point A to point B. What do I mean by that? Starting at point A, we would rise. Remember, we always run vertically first with a slope. We would go up until we got to this point right here. Then we would take a right turn and move over there to point B, making a right angle there. So in that case, everybody, our rise is 4. Since we went up, that's actually a positive 4 there. And our run, then, everybody, is 1, 2, 3, 4, 5, 6. So our run is 6. That's a positive 6 since we're moving to the right. So our rise over run here from point A to point B is 4 for a rise, 6 for a run, and we always simplify that fraction if we can. Dividing out a 2 here, we would get 2/3 for the slope of this line. And that is one of the key pieces of info we need. It's not the final answer, guys, because we haven't written the whole equation in slope-intercept form, but we now know the S. We now know the slope of that. Now, the much easier part here is figuring out B. Now, if we go back here, B, we said, was the y-intercept, and we haven't talked about that yet, so here's our chance. The y-intercept is the one point where your line crosses the y-axis, and of course the y-axis is this vertical one going right down the middle here, and our line in blue crosses the y-axis right here at a y value of positive 1, because this point is located 1 unit above the origin. So what we know right now, guys, is that our slope is 2/3 and our y-intercept is 1. So when I go to write an equation in slope-intercept form, it follows this general pattern, y equals mx plus b, but we need to have values to put in for m and for b, and lucky for us, we know what both of those are. Y is equal to, our slope we said was 2/3, so that's the number that goes in for m. Then the x just tags along right after that, so 2/3 x plus our b value here, which we said was 1. Now, answer the question, guys. Did we come up with the equation of this line in slope-intercept form? This is what we have here, an equation in slope-intercept form. However, one thing I want you guys to get in the habit of doing right here is a great way. You can double check your answer now, guys. If we got this right, both of these ordered pairs right here should work when we algebraically substitute their x and y values back into this equation. I'm going to focus on this point right over here, guys. And remember what we said right here, that the x, y in your equation can represent any point on your line. So I'm going to take this equation right here and take this y value and this x value and substitute these two numbers in the appropriate place. I would start with a y value, which in this case is 5, equals 2/3 times an x value of, well, at that point our x value is 6 and plus 1. So now let's find out if this ends up giving us the true equation we wanted. 5 equals, you guys would probably want to grab your calculator right now and just type this whole mess in there at once. 2/3 times 6 plus 1. I've got a calculator here that looks different from yours. I tell you what, I'll just use the old Desmos Scientific right here, and let's try this. Let me make that a little bit easier to see, everybody. Okay, there we go. So what did we just say we were doing? So 2/3, and I'd like to do that as a fraction right here, so 2 over 3, gotcha. Let me go with a right arrow after that. That is going to get multiplied by our x value, which was 6, and then we had a plus 1 at the end of all that. And you'll see that when I do that, 2/3 times 6 is 4, plus 1 is 5. That's what my right side is now equal to. And sure enough, guys, there is the true statement that I was looking for. 5 equals 5, and that tells me that I think we did this one right. So this is our answer to this problem. Y is equal to 2/3 x plus 1. All right, let's try another one here, guys. All right. This one, I'm hoping you're going to notice, it looks quite a bit different from the last problem. The one we just did, you guys, was a line that was rising as we went from left to right, so it made sense then, I hope, that our slope was positive. But in this line, it looks like our line is falling as it goes from left to right, and that means that our slope should be negative. Now this one, I'm going to do a slightly different way. If you still want to count rise over run, you can do that to get from point A to point B. But what I'm going to do this time instead, guys, is use the slope formula we talked about in 3.8a. y2 minus y1 over x2 minus x1. So I would say that these are my second points right here, x2 and y2, and these over here are my first points, x1 and y1. So for my formula, y2 is going to be negative 2 minus y1, which is 4, all over x2 is going to be 2, and then minus x1, which is 0. That's going to get me a negative 6 on top, a positive 2 on bottom, and that means that my slope is going to be negative 3. Now, if you noticed, if you wanted to do rise over run from A, we would now go down until we hit this point right here and then over to the right. That is a rise of negative 1, 2, 3, 4, 5, 6, so negative 6 for the rise, and a run of 2. Those are the exact same numbers I had right here doing it algebraically, and that still gets us a slope of -3. B is our y-intercept, which is real easy to tell here, guys. Where does this blue line cross the y-axis? Right here at a y value of 4. So we know our slope is -3 and our y-intercept is 4. Let me switch back to blue here. That's what you need to get an equation in slope-intercept form, the slope and the y-intercept. So this is going to be y equals m, our slope is -3, multiplied by x, and then plus your y-intercept, which in this case is 4. So that is our answer for example B. And again, if I wanted to double check that, I would choose, I'm going to go with this point right here, and I would plug this 2 right in here for x, and this -2 right in here for y, and let's see if we get a true statement. The y coordinate we're dealing with is -2, a line right here, gotcha, equals -3 times an x value of +2, and I think this thing ends with a +4, so let's try it. -2 equals -3 times 2 is -6, and -6 plus 4 is -2. Check. That one works out as well, so here's our answer for B. Third and final one of these problems that I want to give you guys looks a little bit different from the first two. The first one we had was a rising line, which meant that our slope should have ended up positive, and it did. The second one we did had a falling line, which means our slope should have been negative, and it was. This one, I'm hoping you guys will notice, we have a line right here that is horizontal. So what I'm hoping you guys can tell me immediately here without doing any work is that because this line is horizontal, our slope is automatically, remember guys, horizontal has the letter O in it twice, our slope is automatically equal to 0. Now, y-intercept, the one point where this line crosses the y-axis, that occurs right over here at a y value of -1, -2. This would be -3 right there for our y-intercept. So even though that 0 might be bothering you a little bit, I'm not going to let it throw off my game. I'm still going to do the exact same thing I did on the last two problems. It's y equals m, which is 0, times x, and then plus your b value, which is -3, so I'm going to write -3. Now, the only weird thing about this is it doesn't matter what x is, everybody. When you multiply x by 0, you automatically just get a 0. So we're going to get y equals 0 minus 3, and we would simplify that to get this equation here, y equals -3. When you're dealing, and I think this is the first time we're talking about this within this chapter, guys, when you're dealing with a horizontal line and you try to put it in slope-intercept form, this is what the equation always ends up looking like. There is no x here in the final answer because we multiplied our x by 0, and that just disappears. Now, the same trick I taught you guys to check the last two still works. If I took this point right here and tried to plug it into this equation, I would put -3 in for this y value here and get -3 equals -3. You'll notice there's nowhere to put that 6 because there is no x in this equation, so the 6 doesn't really matter, and sure enough, we end up with a true statement here of -3 equals -3. And of course, the same thing would have happened if we tried this point right here. We'd still get -3 equals -3, so that tells us we're doing these problems right. All right, guys, so that was kind of an introduction to slope-intercept form and 3 problems where I gave you a graph and asked you to come up with the equation. Now we're going to reverse that skill here, and in the next 4 problems, I'm going to give you guys an equation that's in a form, and then we're going to try to graph from slope-intercept. So in this one right here, we've got y is equal to -2x plus 3, and the first question you probably want to ask yourself is this equation already in slope-intercept form? Does it match the format y equals mx plus b? And the answer to this one here, guys, is yes. What I want you to notice is that it's solved for y over here on the left-hand side. We've got y equals, and then everything else is over on the right. And the other big key is that the right side doesn't have any parentheses in it. Everything is written out. So I'm hoping you guys can look at this equation right now and answer these two questions for me. What is the slope of this line, and what is the y-intercept? Well, m, the slope, is the coefficient, the number being multiplied by x, which in this case is -2. And I want everybody to notice it's not -2x. The slope is the number being multiplied by x, so the slope is just -2. Now, while we're at it, it's almost always useful to make this number into a fraction so we can think about it in terms of rise over run. So anytime you have an integer, you want to just put a 1 on the bottom there and think of our slope as -2 over 1. B, the y-intercept, is the number that's added at the end, and that's going to be a +3. And these are the only two pieces of information we need in order to graph this line. We start with the y-intercept, guys. This line crosses the y-axis at 3. So from the origin, I would go up 1, 2, 3 units and put a big fat dot right there. And I know that my line passes through that point. Now from there, we use our slope as a set of directions. Rise of -2 and a run of +1. So we go vertically now, and a rise of -2 means we go down 2. So from this blue dot, I'm going to go down 1, down 2, and then a run of 1 means we go 1 unit to the right. So we went down 2, right 1, and then we put another big blue dot right there. Now those two blue points are the points that our line passes through. And it really only takes 2 points to determine a line, but it's a good idea, guys, to use your slope a couple more times. I'm going to continue doing this rise and run a couple more times. Down 2, right 1. Down 2, right 1. Down 2, right 1. And at every time I made my little turn there and there and there, those are points that are going to be on the line. I also want to remind you guys that -2 over 1 is actually the exact same number as +2 over -1, meaning what I could have done from this first point right here is gone up 2, that's a rise of +2, and then left 1 for a run of -1. The point is, all of these blue points here, you guys, are collinear. So now I draw the one and only line that connects all of those points, and I am done. I have answered the question. I have graphed this line. Now, did we get it right? Okay, let's talk about that. The best way to check this, everybody, is to pick a random point on your line, like, I don't know, I'm going to go with this one right over here. Now, we got to figure out the coordinates of that point. So from the origin, guys, that is 1, 2, 3, 4 to the right, and then down 1, 2, 3, 4, 5 units. So that's the point 4, -5. Now we believe that this point is located on this line. So how do we check? We substitute and we make sure we get a true statement. In for y, we put our y coordinate of -5. That equals -2 times an x value of, right there, an x value of 4, and then +3. And let's see if this works out. On the right side, I hope you guys can do this in your head, -2 times 4 is -8, and -8 plus 3 makes -5. Check. That is the true statement we were looking for. If my life depended on it, I might maybe pick another point like this one here, which looks like it's -1, +5, and I might do the same thing again, but I'm pretty confident that's going to work out. Okay, so that's how we graph a line out of slope-intercept form. If we were in class right now, I'd have you guys try this one on your own, so you might, if you're feeling adventurous, just want to pause this video and see if you can get this one on your own, and then come back and see how we're doing. Okay, hopefully you tried that, guys. Okay, are we in slope-intercept form? Yes, we are, because we're solved for y, and there's no parentheses on the right. So m is the slope, the coefficient of x, and the x here is being multiplied by a fraction of 3/4. B, the y-intercept, is the number that's being added at the end of this equation here, and that is going to be a positive 4. So with those two pieces of information, we should be able to graph this. We always deal with the y-intercept first, everybody. A y-intercept of 4 means that from the origin, we go up 4 units and put a point right there. Then we go to our slope. Our set of directions right here is to rise 3 units and run 4 units. So let's try that, guys. From this point, I would go up 1, 2, 3, and run 4 units to the right. 1, 2, 3, 4 would get me to right about there, and then I have another point there that this line passes through. Now, I'd love to tell you to do that again, but if I tried to go up 3 and right 4, you'll notice I'm kind of off the graph. So another thing I might focus on is this weird little idea that 3/4 is actually the same thing as -3 over -4. A negative divided by a negative is also positive. So from that initial point, I could also try rising -3, which means go down 3, and then run -4, which is left. 1, 2, 3, 4, and that gets me to that point right there. And I have room to do it again, down 3 and left 4. There you go. And that would get us to this point right here. And so, everybody, that in blue is the line that I'm looking for. I probably should have said on the last example, what I did here in red isn't really part of the graph. I drew that so you guys could kind of follow where I was going and how I got there, but that does not need to be included as part of your graph. It is just kind of the staircase on a hill that might help you a little bit. Now again, that's our answer right there. The directions were to graph that line, and I think we've done it. However, I always think it's a great idea to double check a point here. So let me go to purple, and let me pick, I don't know, how about this guy right over here? I believe that ordered pair is 8 units to the left of the origin, so -8, and then 2 units below the x-axis, so -2. When we plug those values into this equation, we should end up with a true statement. So our y value there is -2. That should equal 3/4 times an x value of -8 and then a plus 4 at the end of all that. So let's try it, guys. -2 equals, and I'll do this one on the calculator with you guys, 3/4 times -8. Let me run with that. So 3... No, that didn't work out. Let's try that again. Let me do the fraction first. Here we go. So 3/4, okay, and then in parentheses, that was getting multiplied by a -8, close the parenthesis, and then we had a, I think a plus 4 at the end of that? Yeah, so 3/4 times -8 plus 4, and that gets us -2, which is exactly what we were hoping for. -2 does equal -2. So check mark, this one is right also. Okay, 2 more examples right here, guys. The next one, this one bothers people just a little bit. The first question I would ask you is this equation in slope-intercept form? And people sometimes get bothered because they expect to see something that isn't here. Yes, this one is in slope-intercept form, and let's talk about why. The 2 things I told you to look for is this. Is it solved for y? Yes, it is. Y is all by itself on the left side, and there are no parentheses on the right. Now, what people get upset about is they think there should be a plus something at the end of this equation right here, and there's not. But I would just ask you guys to use your imagination. What number can you add there that's not going to change anything? That is just like having a plus 0 at the end. And so, we should be able to tell that the slope of this line is the coefficient of x, so -5/2, and b, the y-intercept, is the number added at the end. That's going to be a 0. So as we said before on the last 2 problems, guys, we actually start worrying about the y-intercept first. And with a y-intercept of 0, we know that this line has to pass through the origin. Now we use our slope, -5/2. So rise over run, that means we are going to go down 1, 2, 3, 4, 5 units, and then run positive 2, which means 2 to the right, and that gets us right there. Now you might want to think real quick. Our slope was negative, which means that this line should be falling as you read it from left to right. And you can tell already from these 2 points, if I were to connect them with a straight line, yes, this line is going to be going down from left to right. The other thing I would remind you guys is that your slope of negative 5 over 2 is actually the same as positive 5 divided by negative 2. You can just move that negative to one side or the other. That would mean that we could have a rise of positive 5, 1, 2, 3, 4, 5 units up, but then a run of negative 2, which would take us 2 units to the left. Both of those are good, guys. You'll notice it still gets us 3 collinear points, and that's good enough to go ahead and draw this line that goes between them. So that's what the line y equals negative 5 halves x looks like. Okay, so hopefully we're starting to get the hang of this. Last problem, and this one bothers people just a little bit, is this one. The equation now is 3x plus 5y equals 15, and you'll notice this one is definitely not in slope-intercept form. This is in something called standard form that we'll talk about a little bit later on in this chapter. So the only thing we've been doing so far, guys, is graphing out of slope-intercept form. So that's the first thing I'm going to tell you to do here, guys. If your equation is not in slope-intercept form at this point, let's put it into slope-intercept form, because that's the only form we know how to graph out of. So the one little tip I'm going to give you here, everybody, is this. When we talk about putting something in slope-intercept form, you guys just need to know that that means solve for y. Okay, let's put a big box around that. We're going to get y by itself in this equation right here. So what are we going to do first to isolate the y? We need to get rid of that 3x term by subtracting 3x once on the left and once on the right. Those terms cancel, and we now have 5y equals. Guys, these are not like terms, so you could just write it as 15 minus 3x, but people usually like it better with the x term in front. So I'm going to make that negative 3x and then plus 15. And the last thing we have to do to isolate the y is divide by 5 on all 3 terms in this equation here. The 5's cancel. We end up with y equals. Now, negative 3 does not divide it all by 5, so we just leave it as a fraction. Negative 3 over 5x. And then plus 15 divided by 5 is going to get us a 3 at the end of that. So here's that equation, you guys, in slope-intercept form. Might even want to write that down. We got it to SIF. So what is our slope, everybody? That is going to be negative 3 over 5. What's our y-intercept? That's the positive 3 at the end, and that's all we need to graph. A y-intercept of 3 means I go up 3 units from the origin and put a dot right there. A slope of negative 3/5 means we rise negative 3, so we go down 3 units. So 1, 2, 3, and then we run 5. 1, 2, 3, 4, 5 to the right, and that puts us right here. I think I have room to do that again, guys. Down 3 and right 5 would get us right here. Or we could reverse that to make it 3 over negative 5, which would mean we would go up 3 and left 5 units and get to this point right over here. And then I'll just go ahead and draw the one line that passes through all of those points there. And that is the equation of the line we were looking for. Let me play around with this point right here, guys, which has the coordinates of negative 5, positive 6. I'm going to take that and go back to the original standard form equation, and we're going to see if we can get this to work out. So I'm just following the format of the original equation here, so it's going to be 3 times an x-coordinate of negative 5. What's next then? Plus 5 times a y-coordinate of 6. And all of that should equal 15. Let's try it. 3 times negative 5 is negative 15. 5 times 6 is 30. That should equal 15. Negative 15 plus 30, sure enough, 15 equals 15. So yet again, we got this thing to work out, and that tells us that we're getting these graphs correct. Okay, guys, that's about everything we wanted to cover here on slope-intercept form. Let's give that 3.8b worksheet a chance, and let's see how we do at it. Good luck, everybody.